Good morning, afternoon, evening, everyone. A very warm welcome to Exploring Seamless Pressure Vessel Modeling with BricsCAD webinar. I am Aman Jain and I'm thrilled to be your presenter today for this insightful session. We are about to start on a journey through BricsCAD's innovative solutions for pressure vessel design and fabrication. So, get ready to discover the tools that can streamline your workflows and empower your engineering projects. This would be the agenda for the day, wherein we'll start by introducing Bricsys, who's a leading provider of innovative CAD and engineering software. And then, as we delve into the world of pressure vessel design, we'll discover how BricsCAD empowers engineers to create intricate models. Moving forward, we'll explore BricsCAD Mechanical and its role in streamlining the fabrication process, thus enhancing accuracy in manufacturing drawings and also simplifying assembly instructions. One standout feature of Bricsys is its seamless integration of tools, allowing you to smoothly transition between design stages. And finally, we are excited to address your questions during the Q&A session, so feel free to engage and gain deeper insights into how Bricsys can elevate your engineering endeavors. So let me begin by introducing who is Bricsys. We are a part of Hexagon AB, a large global technology group which have had revenues in the year 2021 of almost 4.35 billion euros. Many of us here are already aware of what Hexagon is, so we do have a solid foundation, and you can be certain we will remain strong and dependable into the future as well. We have a huge customer base of over 400,000 satisfied active users in over 110 countries throughout the world. We were established almost 20 years ago in Ghent, Belgium, which remains our global headquarters. We have a total of 8 offices throughout the world with almost over 300 employees, and we are supported by an extensive network of specialist partners and resellers. We, therefore, can offer a local personalized service, but with the backing of a huge multi-billion euro group. So let us talk about the challenges today's industries are facing. We'll start with learning curve and skill gap, wherein adopting advanced CAD tools demands training and upskilling. Bringing the skill gap among employees becomes a challenge, and we need to ensure that their workflows is well versed in using sophisticated CAD software to maximize their productivity and maintain design quality. The next one, and the most important one, is in terms of escalating costs of software ownerships. Since as CAD technology is advancing, the cost of software ownership is escalating as well. Manufacturers need to carefully manage software licensing, maintenance expenses, and updates because balancing these costs while ensuring access to cutting-edge CAD tools poses a significant challenge. And the next one, last but not the least, is in terms of integration and interoperability. Because in this very complex landscape of modern manufacturing, CAD systems must seamlessly integrate with various software tools. Pressure vessel design involves simulation, analysis, and manufacturing stages, and lack of interoperability can lead to nothing but data bottlenecks, errors, and inefficiencies in information exchange. Delays and misunderstandings can arise when engineers, designers, and other stakeholders can't easily communicate and coordinate on the same design. BricsCAD is trying to close this technology gap. The technology gap in terms of software costs versus software capabilities. In the graph, if you see, the low-cost tools have very little to offer in terms of capabilities, whereas highly capable tools are extremely expensive, thus creating a huge gap with no one in the market providing optimized capabilities at an optimum cost. This is where BricsCAD comes in. BricsCAD is a comprehensive design platform offering a vast range of capability from basic 2D drafting through the advanced 3D mechanical design in one single environment, and everything is in .dwg. There are hundreds of advantages of having everything in one single environment in one single extension, wherein there's a seamless transition between 2D to 3D as well as 3D to 2D, plus for in terms of the users getting used to that particular environment, it's really very simple. It sits squarely in that zone where the technology gap exists. BricsCAD is an advanced intelligence solution which goes way above and beyond the capabilities offered by those traditional manual 2D products. It offers a comprehensive set of tools that helps you meet those critical needs of efficiency, flexibility, and innovation, really enabling you to supercharge your design to manufacture process. But crucially, it does in a way that is accessible for all manufacturers, including those who are smaller or mid-sized. It's way less complex and costly than those mainstream and advanced solutions and is much easier to adopt. So, without further ado, let us take a look at how BricsCAD can help to supercharge your pressure vessel design workflows. And here we start off with the primitive shapes that are readily available in BricsCAD. For example, we'll start off with a sphere by drawing it at the center with a certain radius, and then we start off with a cylinder and we'll draw it on top of the sphere and then use the Boolean operations to merge them both together. Now this is what the power of direct modeling looks like. BricsCAD is completely direct modeling, but none to confuse with parametric modeling because it is parametric as well. Direct modeling allows you to model the way you want without actually keeping the end result in mind. You can simply go ahead with the modeling activities without having the design intent placed in your mind right from the start. So here, as you can see, I'm having or using the 2D commands of move on the 3D model itself. So this is how I can very easily manage those changes within the BricsCAD environment, be it 2D or be it 3D. So let us change the height of this tropospherical vessel that we have created. And right now I'm using a top-down approach of assembly modeling, wherein I've created the entire model in one single file and then we'll split it out and create an assembly out of this entire model that we create. This time around, I'm just extracting the edges so that I'll be able to reuse these edges for creating this offsets to create my top dish and bottom dish. So here, as you can see, I'm no longer creating those sketches again and again. I'm just reusing whatever is available to me right on my very screen. So let us split open this vessel by using the slice command that's available in BricsCAD. So we use slice at the top end, at the bottom end as well. And now we'll just select these two edges and delete it. And the vessel has been sliced open. So if I hide this particular top dish, it's been offsetted internally with a thickness of 5. Now I can bring it back. Let's save this model because I wanted to show you how we can save this in a format that every one of us is used to. So it's .dwg. The next part is where we create the flange, again by using the existing edges and the faces and not by creating any more sketches. So I'll use certain direct modeling features, like this one is push-pull, wherein I need to reduce the flange thickness. Then there's this library component that I can use to place holes for fasteners at a later stage, which I'll be inserting again using my library components. And as you can see, the hole itself is parametric, wherein I was able to change the radius and the depth of the hole that I'll be placing on the flange as well. So I just use an array to create an array of those holes across the flange, increase the number of line items depending upon the requirements, and then use the same geometry to extrude and create a new component, which would be my gasket. So as I said, we are using a top-down assembly approach, and I'll not be creating components separately and bringing them together. I'll be creating components within the same file, and now I can save this as a component, say gasket, and this is now saved as a separate component, as you can see in the mechanical browser on the left hand side. So I've hit it. I do the same with flange as well by using form component feature in BricsCAD, and I'll create a new component called flange from the existing geometry that's available. So now two components that are available called flange and gasket, and now I can insert one more flange on the vessel side. So this was on the dish side. Now I'll just insert on the vessel side to make my assembly complete. So let us place some constraints, and as you can see, placing constraints is not a very easy task. It's not that complex over here as well. So there are two flanges, one gasket, and let's save this drawing again. As step 4. The next part is we'll bring the lug supports in by inserting components. So I have some readily available parts, and this is the leg assembly, which I'll just place at its own insertion point, and it's automatically mated on the vessel itself. I'll array it because I want to create 4 instances out of it. So let's reduce the number of items to 4. And if I go on the top view, I need to change an angle. So let's give it an angle tolerance. I can go to the constraints part, give an angle constraint to it, select the source item or the entire array or blocks as an object, select the Z axis across which I want to move it, and then give it an angle of 45 degrees. So my lug supports have been placed. I'll save this as again. Now the reason I'm saving it because I want to make this available for all the audience who's present today in the webinar, in case if they need it for reference and see how it's been modeled in CAD. So right now what I'm trying to do is trying to insert nozzles. Again, very simplified version of it. Just insert the nozzle and place it at the coordinate that you would want to place it upon, and I'll just set right over there. I can use snap points like I use it in 2D components, wherein if I want to snap on top of this particular face, I can snap it on to the center, and that's done. It's just got placed. Likewise, I'll keep inserting a few other nozzles to make my pressure vessel complete. So there are 2 ways in which you can place your nozzles in. You can have reference dimensions or reference entities to be able to place your nozzles using those references, or you can use your coordinate systems to enter those exact coordinates and positions where you'd want your nozzles at. So right now I'm using coordinates, as you can see in the status bar on the bottom of the screen, and that is where the nozzles are getting placed. That's it. This has now been placed completely. You can save this as again step 5. And now let us see how we can use reference lines or reference entities to be able to place our nozzles at. So I'm trying to showcase both of these methods, and we can use whichever is feasible or possible for us to be able to use it. Again, both of these are simplified ways because if we rather see on how do we do it in other CAD systems, it's a bit complex over there. So in this case, I just create I just use BricsCAD's 3D entity snaps, wherein I'll place a point at the intersection between the lines and the faces. As you can see, I'm able to detect that intersection using the Z intersection snap, and I'm just placing points over there. Now those points will act as references for me to be able to place my other nozzles or the other whole components that I'd be using now. For me to be able to see these points very clearly, I'll just change its color to red, and then just increase or change the point display mode to a bit of a higher value. So let us go here, enter 3. Yeah, and now I can see those reference points on my screen. So let us bring a whole component and let us try to place on top of one of the points that we have created right at the center on the BC subtract layer. That's something that if you need an explanation to, I can give it, but rather it's a layer that would subtract entities when it's under that particular name. So we'll just place it on that point using snaps, and now my circular hole has been directly placed on that particular position where my point was, and as soon as I off my layer, as you can see, it has subtracted the material from the top dish. I can insert another component, let's say a manhole or handhole, and I can again use entity snaps to be able to place this particular component on the reference point that I placed earlier. Similarly at the bottom as well, we use this to be able to place it. We'll use the snaps again. It's really simple this way. And as you can see, for the entire assembly, I can adopt this particular method as well. And in case if I do need to apply constraints after this, I can still apply it after placing the components at their usual references. So let's say if I want to rotate it at an angle of 20, 25, 30, 45 degrees, whichever, I can still do it. So this is how I can create my pressure vessel in BricsCAD. I'll save this as again as step 6. And now let us try to place the fasteners in the holes that we had created on top of our flanges. So again, placing of this particular component, it's really an easy task. I'm just using snap points to be able to snap onto the centers of those geometries, and these are already placed. If I want to insert a pin, I can simply insert a pin using the geometric center snap again. But first I just choose the type of pin that I'd want, select the parametric dimensions from the right hand side, and now the pin is placed. I can use push-pull command or even move command to be able to move it across the bolts and reposition it. And then once this is done, I can simply array it. Use polar array option, increase the number of items so that each individual hole has this particular fastener assembly, and my vessel is ready. I'll save this as again as, and just one more thing, you can always share this DWG with someone who is not using the latest version of CAD. For example, if someone is using BricsCAD V21 or even any other CAD of a lower version, they can still open this file because it's DWG. So this is another added advantage of having everything in .dwg. Since you've already seen on how to model a pressure vessel in BricsCAD, let's now take a look at how BricsCAD can help the streamline creation of fabrication drawings. Now this is another interesting aspect of BricsCAD, wherein once the 3D model has been created, we can very easily create the fabrication drawings for it, as well as we can create the bill of materials, do the auto ballooning, and this is something that we'll be seeing. This is where we ended. The next part is setting up for creating our fabrication drawings. Now before that, there's some settings that I'll be doing using some of the commands. Say form component, because this is something that I want to show, wherein I'd be creating a component out of this bottom dish, and then once this component is created, it sets it as an external component and I can open it. Now give it a material of my choice. So let's say ASTM, A240, and standards that I want to use. Any other properties that I want to change in terms of densities, specific heat, as well as thermal conductivity as well. Once that's done, I'll create a key, add a description to my component. So once I've added the description, I just save this file. Now, since this is externally saved, whatever updates I make to this particular component will be updated back over here in the main assembly as well. So here's the material, here's the description, and that's done. So I can do this for each and every individual component, and it's completely my choice whether I want to keep it as an internal component, wherein again I can make some changes to it. Else I can keep it as an external component and use it elsewhere in other assemblies as well. So here I'm inserting a few more components wherein this particular assembly has been brought into BricsCAD. And we'll just use again the regular snaps to be able to reposition it on top of that particular nozzle on which I'm trying to place it. And this is all possible because of dynamic UCS that's available in BricsCAD. So let us now insert a few more components. And the way BricsCAD treats its DWG models is in a very super light manner. So even in cases wherein there are large number of components, there are large number of parts that are getting involved in a particular assembly, BricsCAD is still able to handle it with a lot of ease because since everything is in .dwg again. So there's the mixer that I want to be able to insert it in the hole that we have created in our last session. And we'll just use constraints to be able to reposition it over there. The concentric constraints should realign by making the centers same, and then we can use flush constraint, distance constraint, coincident constraint to be able to reposition it exactly. That's done. Now comes the fabrication part, wherein if I were to choose a template, I can simply choose a template. There's an existing template that I have. And if I go to that particular template, the title block and the annotations, the weld annotations have already been mentioned. So I can have a predefined set of template that I can use to create my drawings. I click on base views under the annotate tab to be able to create the base views for my vessel. And there are a list of options that are made available to me in terms of the type of orientation that I want to have, hidden lines, tangent lines, the type of angle of projection that I want to use, so on and so forth, and even scale of the particular view that I want to put in my paper size. So I'm not placing this particular view, and since it's a bit of a heavy model that we have created right now, it might take a bit of time to create all those edges, curves, faces, etc. So yeah, we'll just have to be a bit patient. And here's my first view that I've been able to create successfully. We can even select individual parts. For example, let us select the mixer. And once I selected the mixer, I can create a view out of it. So I don't have to rush or go to a separate window for me to be able to create drawings for individual components. It's very well within the same assembly that I can select individual components and create the views in the same layout as well. So I'll be able to place it now, but let me just change the orientation for it. and that's done. Let us now create a section view for this particular view that we have. So I can create section views from existing views that we have placed. And once the processing is done, we should be having our section view in place, wherein we'll be able to see the internal components as well, since we have taken section halfway through. So just wait for a couple of more seconds. Yeah, and there's the section view that is there. Right, I can just delink it for me to be able to place it anywhere in the view. And now I'll just rotate it so that it's just upside down in the correct orientation. So I can use my 2D commands to be able to rotate it, and I can very clearly see the internal components as well. I just hide this layer so that I don't want it. Right, so I have my top view, I have the section view wherein I can see the internal components as well. So this way we can create a whole bunch of views for a pressure vessel. I kept some views ready. Wherein since we have very limited time, we have kept the steps ready for you. Just create a new layer called as dimensions as well as balloons, wherein we'll be showing the ability of BricsCAD to create bill of materials, to be able to annotate your drawings, and to be able to create auto balloons as well as balloons in a manual mode. So we'll see how easy it is to create your fabrication drawings within BricsCAD, as well as since everything is in .dwg, if we were to export this particular layout in .dwg, because there are cases wherein you might not want to transfer or share your 3D models. So you can simply export this particular layout to .dwg, and what happens after you export is the entire entities, whatever has been placed in your layout. For example, it could be text, it could be mtext, it could be dimensions, it could be the bill of material table, it could be balloons. It's maintained as it is, so that in case if you want to edit something in the 2D layout, you'd be able to do it. So as I was mentioning earlier, the transition between 2D to 3D and 3D to 2D is seamless, wherein you can use an existing DWG to be able to create your 3Ds, and you can use this 2D that's been extracted from the 3D again in the 2D interface to be able to work on top of it. So right now I'm using the regular annotation commands within BricsCAD. So these are just the dimensions that I'm trying to enter. And a few more. So for example, I can add linear dimensions, I can add diametricals, radial, aligned, baseline dimensions, continuous dimensions, so on and so forth. And of course, the way the dimensions looks are all customizable as well, because it's simply changing the dimension styles, and all of this particular dimensions, let's say if you'd want it in a different set of a color, it'll get updated based on the dimension styles that we use. And in fact, very recently BricsCAD has now introduced GD&T as well, or we call it as power dimensions, wherein if you'd want to introduce GD&T to your manufacturing drawings, you'd be able to do it within BricsCAD as well. and you can give your bell symbols, surface texture symbols, your other dimensional tolerances, etc. So now let us create the bill of material for this entire pressure vessel model that we have just created. And we'll place this form right over here in the model itself. As you can see, there are a lot of components that are within the pressure vessel model that we have. We can simply scale it down for us to be able to fit it within the drawing itself. And it's come as a table. We can edit it. And with the help of the new bill of material manager, it's really very easy for us to be able to customize the bill of material table the way we want it to customize. We can even export this bill of material to Excel using XLSX or CSV formats. And we'll just rearrange the columns a bit for us to be able to fit in. Now, based on this particular bill of material that we have created, we will, so let me just adjust this a bit so that it's perfectly fitting in within the drawing template. And now, based on this particular bill of material that we created, we'll be introducing or creating balloons for the components that are placed inside the 2D drafting or layout environment. So let us go to this particular view and change the layer to balloons. And first off, let me just show you how we can place balloons manually. So as soon as I click any of the component, I'll take in the particular number that's been assigned to that particular component in the bill of material that we just placed. And you can always confirm it with the number that's been assigned to those particular components in the table, but nonetheless it's always 100% accurate. So the manual approach can be used more often wherein there are a lot of components, and then we would want it to look or just place some balloons in certain views and some balloons in another view, so that way the manual approach can be used. Else we can always use the auto balloon option as well, and BricsCAD supposedly uses the auto ballooning feature to be able to identify the parts whatever are visible in that particular view, and I'll auto balloon that particular view. We'll say this again, and this will be the last step for us. And that's done. Moving on to the next part, wherein we see seamless integration of powerful tools. Now, this powerful tools is something that everyone is definitely aware of being in the pressure vessel market. This are something again from Hexagon group of companies, and this is the integration that we regularly use in the oil and gas segment or any other segment that deals with pressure vessel. So very easily we can do the original equipment modeling and designing inside CADworks, which integrates with BricsCAD. The BricsCAD platform can be used as an interface to run your CADworks license, which then can export that particular equipment model into .pvdb format. The .pvdb format can be then opened into PVLite to be able to analyze, and then we can make the required changes based on the analysis data that we receive from PVLite. We can export it back to .pvdb format and then import it back to the CADworks equipment on top of BricsCAD. Once it's imported, we can use that particular assembly or the model within BricsCAD to be able to create the internals, and as we already seen, to be able to assemble as well as create the fabrication drawings for it. Now this interface closes the loop and removes the workflows which are usually are in silos and does take a lot of time for the end users to be able to communicate between these high-end powerful tools. Wherein if something gets created in a CAD tool, that's something not be able to recall it in something like PV-Elite. And then PV-Elite, once it analyzes the model based on whatever we have designed, will not be able to pass it on to that particular CAD tool, and we'll just have to recreate the entire thing. So this is what has been addressed through this integration in BricsCAD. And not just that, of course, we have seen the extended capabilities of BricsCAD in terms of creating fabrication drawings, in terms of being able to itself create a pressure vessel model, and also in terms of importing file formats in the native extensions. For example, BricsCAD is capable enough to import files coming from softwares like Inventor, coming from softwares like SolidWorks, or CATIA, or NX, or any other 3D tool that's available in the market. So with that being said, let me just showcase that particular integration. This integration shows how we can use CADworks equipment which uses BricsCAD as a platform wherein we can model our pressure vessel using CADworks equipment features, and then we can export it out in PVDB from within BricsCAD using CADworks equipment. This particular PVDB can then be imported inside PV-Elite. So let us make these changes. We can then export it out into PVDB and import it into PV-Elite. We can then use this model to run the analysis upon based on the conditions that we would want to use inside PV-Elite, and then make the necessary design changes based on the analysis results. Once the results are in, that particular model can be then exported out to PV-Elite and brought back into CADworks equipment, and we can use this model further to make further designs or assemblies inside the BricsCAD interface. So here we are inserting the mixer, and we can insert many more other parts wherein we can use the BricsCAD interface for further assembly modeling. As I outlined a few minutes ago, BricsCAD closes that technology gap for manufacturers by providing powerful, intelligent tools to supercharge your workflows while being accessible and affordable. Let us take a look at how it does this in more detail. Firstly, the accessibility aspect. So as I mentioned, design technology that can really offer manufacturer improvements in efficiency, flexibility, and innovation is often not a realistic proposition for everyone. It's costly, it's complex, and provides much more than is realistically needed. It also tends to be unfamiliar and not compatible with current CAD products being used. So for many, it's a step too far and overkill for what they actually need. BricsCAD aims to make mechanical design easy and accessible. So firstly, as it's a DWG based solution, it's compatible with whatever you are likely to already be using. So it can be introduced gradually and fits right into your existing workflows at the point it's most needed. So whether you design in 2D, in 3D, or both, it's the perfect fit. And not only it is DWG based, but it has a familiar look and feel to those who currently use other legacy 2D DWG based products. So it's easy to learn and understand, and you can get started right away. And making it even easier to use, it eliminates the complexity inherent within history-based, fully parametric CAD products, so it's so much simpler to understand with few unfamiliar concepts to learn. All features from the most basic 2D to the most sophisticated 3D tools are found within a single integrated consistent platform. So it's simple to move up from a fundamental 2D to an advanced 3D mechanical workflow without having to learn a completely new product. In terms of affordability, BricsCAD has a much lower cost of entry than other 3D mechanical design solutions and even than many lesser basic 2D and 2D mechanical design products. And there is a typically much lower cost of ownership than other products too, not least of all due to the flexible range of perpetual and subscription license options that we have to offer. So these are what your next steps should be. Start your free 30-day trial by downloading BricsCAD from our website. You can go to www.bricsys.com. You can ask for a technical demonstration from anyone from our team who will directly engage with you or probably with some of our resellers that are already available in your region for your service. We can always discuss about how easy the migration part would be, and we'll be happy to answer any questions that you have. We are there to provide any essential training that your team would need in terms of adopting BricsCAD, and we are always there, so please do ask for help and we'd be happy to help you. I hope this webinar was really insightful and was able to give a lot of values in terms of how BricsCAD could potentially offer a lot of benefits for your organization in terms of technical as well as commercial aspects both. So thank you once again for being here, and do visit us at bricsys.com. Please feel free to download your free 30-day trial and let us know in case if you do have any queries. So thank you once again. Wish you all a good day ahead. See you next time. Bye.